Hello everyone. So in this video we are going to continue from task 3 of this project, see recursion. So this task here says we should write a function that returns the factorial of a given number. This is what the function prototype, and this parameter here is the number in which we want to find the factorial of. It says if n is lower than 0, the function should return a -1 to indicate an error. Factorial of 0 is 1. So let's understand what the factorial of a number is. So assuming I have, let's say I want to find the factorial of, let's say 5 factorial. So 5 factorial is simply going to be what? 5 times 4 times 3, right, times 2 times 1, right? This is simply 5 factorial. So this 5 factorial here, it can be represented in this format here. So one thing you need to know about recursion is you need to split your problem into smaller, simpler problems. Okay, so how can I split this now? So this is the same thing as saying 5 times what? Times 4 factorial. Isn't it? This is the same thing as saying 5 times 4 factorial. So, and 4 factorial here, if I'm trying to find the 5 factorial of a number, I need to represent it as something like this. But I cannot get the answer of this because I need to know what 4 factorial itself is. Right? Because the answer to this depends on what the factorial of 4 is. So I can move ahead and say 4 factorial now is the same thing as 4 times what? Times 3 factorial. So I need the answer to this, right? For me to feed it back to 4 and then compute the answer. So also for this, I cannot get the exact value until I know what 3 factorial is. So this is the same thing as saying 3 times what? Times 2 factorial. So also in this case, I cannot be able to get the solution until I know what 2 factorial is. So this is the same thing as saying 2 times 1 factorial. Right? So now we all know what 1 factorial is. Right? 1 factorial is 1. Isn't it? The factorial of 1 is 1. I think they stated it in the question. Okay. Factorial of 0 is 1. Factorial of 1 is also 1. Okay. So now we've reached the end. So here I can just say factorial of 1 is what? Is 1. So what I'm going to do here is, now I have this one. I've reached the last stage, right? I found that 1 is the factorial of 1, right? So I can replace this with the value 1. So this is going to be stored here now. I will feed back the answer to this one because it is what? It is the value of the factorial of that one here, right? So now I have what? 2 times 1 here, right? 2 times 1 is what? Is 2, right? So this 2 here will now be fed back here because the whole of this 2 times 1 here is what? Is this 2 factorial here. So I can replace this 2 factorial with the value 2 now, right? I can replace with the value 2 because I've already found the factorial of 2, which is 2 here, right? So now I will compute 3 times 2, which is what? 6, right? So this will give us what? This will give us 6. So this 6 here will be fed back here because 6 here is the result of what? 3 factorial. So I replace this 3 factorial with 6 now. Do you get it? So now, what is 4 times 6? 4 times 6 is what? 4 times 6 is 24, right? So this is going to give us what? 24. So if you feed 24 back here, because 24 is represented by, 4 factorial is representing 24. So I can simply replace this with what? With 24. Right? I've replaced this with 24. So this is going to be what? 5 times 24. Let me open my calculator. This is going to be 5 times 24. So 120. So this is what? 120. So 120 here is what? Factorial of 5. So 5 factorial is equals to what? 120. Did you see that? So what happened is I replaced, or I split the problem into smaller problem. Right? For the first case here, I have 4 factorial here. Let me just rewrite this. I have something like this. I said 5 factorial is the same thing as what? 5 times 4 factorial. Right? 4 factorial is the same thing as 4 times what? 3 factorial. 3 factorial is the same thing as 3 times 2 factorial. 2 factorial is the same thing as 2 times 1 factorial. And 1 factorial is 1. And this value here, I kept sending it back to the what? To the previous call to the function. Right? To the previous call to the function. So it means that for me to find the factorial of a number, what is this here? Assuming the number 5 here is the n, the number we want to find the factorial of. So I can simply say n, because this 5 here is the n, right? N times what? 4 factorial. So how can I get 4 from n? I can just say this is going to be n times what? N minus 1 factorial. This is what the pattern now. So now we've generated the pattern that will give us the factorial of a number. If I have, let's say 6 factorial, I want to find the factorial of 6. This is going to be what? 6 times what? 5 factorial. Right? So what is 6 here? My 6 is n. So I can generate my pattern to be equals to what? This is what? N here, because it is 6. So it's going to be n, this multiplication times, and then what here? 5 is what? N minus 1, because n is 6. So this is going to be what? I can now call the function again, because this is also a factorial problem. Right? So we need to call the function again and pass this factorial to it. So assuming the function name is fact, so I'll just call fact, and then in fact I will pass what? 5 minus 1, sorry, 6 minus 1, which is 5. So in this case it's going to be what? N minus 1. So now we've generated the pattern. So this pattern here would give you what? The factorial of a number. You simply just say n times what? Call the function again, since it's a recursive call and you are passing another factorial, and then you pass what? N minus 1. Do you get it? So now we've generated a pattern to solve this problem. Okay, so what I'm going to do here is I'll open the file. This is task 3. Alright, so factorial.c. So as you can see, I have my Betty documented. So here, what I'm going to see here is I have a condition to check. Right? We have a condition to check. So here it says if n is lower than 0. So I need to check that. Right? If n is lower than 0, then what should happen in this case? We are going to return a negative 1. Right? So return minus 1. Isn't it? That's what the question says. So here we need to check for 0 as well. The factorial of 0 is 1. Right? The factorial of 0 is 1. So I need to check if the factorial of 0, if n is equals to 0, then it's going to return 1. So I can just say if n is equals to 0, so what should happen? I can just say return a 1 here. Sorry, this is supposed to be else if. Yeah. So here, this is what we need to do. So else, that is, if it is less than, if it is not less than 0, if it is not equals to 0, this is where we need to do the work. So I'll just say return. I've already generated the pattern, right? I'll just say return. What should be the return value? We are going to say n, right, times what? I will call the function factorial again. So I pass in factorial, and then I will pass in the parameter again, right, which is going to be what? N minus 1. This is exactly what I explained here. I've explained everything here. I've explained to you why we got n, and I explained to you why we got n minus 1. Just look at the pattern here. As you can see, here it keeps decreasing by 1, keeps decreasing by 1, keeps decreasing by 1 from n. Do you get it? So that's just how this function is supposed to look like. Okay, that's just how the function is supposed to look like. So let's run this. Let's run Betty on this. So Betty factorial. All right, so Betty is fine. So let's create the test file. So copy vi 3 main.c. All right, so paste this. So here I'll just say #i. All right, so let's run the compiled file and let's see if we will get the exact output. So copy, this is paste. Good, so it has been compiled. So let's run it. So let's see the output. Yeah, so as you can see, we got the exact output, which is 1, 120, 3680, and minus 5. So let's look at this. This first case here, factorial of 1 is 1. Factorial of 0 is also 1. So that's why we are getting what? A 1 here. And here, factorial of 5. We found the factorial of 5 on this print here, and we realize that it is 120, right? So this shows that our answer is correct. This is 120. And the factorial of 10 here is this. And the factorial of minus 1024, since it is negative, we are told to return a negative 1. So that's why we are having something here. Okay? I believe this is clear. So don't forget to add, commit, and push to your GitHub, and then you can run your checks. So we are going to stop here. In the next video, we are going to continue from task 4 of this project. So thank you very much. To meet in our next session.